Okay, so moving on now to the next important concept, right? I want to talk about the different forms of a complex number. So far, the form of a complex number that I've shown you is what's called Cartesian form. Okay, so the Cartesian form of a complex number, that's when you have x plus iy. A number plus I times another number. This is called Cartesian form. And so Cartesian form is when you think of a complex number in terms of its real and imaginary parts, essentially. That's all it is. Another popular way of thinking about complex numbers, so instead of Cartesian form, what you can do, you can think of a complex number in terms of its distance from the origin and the angle it makes with the horizontal axis. So let me explain what I mean. Let me make a little drawing here. Okay, so let's say this is the complex plane. So again, let's say this is the real axis and this is the imaginary axis, okay? And let's say I have a complex number here corresponding to x plus iy, right? So when I'm thinking of it in Cartesian form, I'm thinking of it in terms of its real and imaginary parts. So x plus iy, where x is the real part, right? And y is the imaginary part. But what I can do instead I can think of it in terms of its distance from the origin, right? Call it r, and the angle, we'll call it theta here, that it makes with the positive real axis, right? So instead of thinking of it in terms of its x and y coordinate, I can think of it in terms of r and theta, where r is its distance from the origin, and theta is that angle it makes with the positive real axis, okay? And I can derive expressions for r and theta using simple trigonometry. So if I form a little right angle triangle here, so if I draw this up, make a right angle triangle here, right? I can see that the horizontal edge will have length x, and the vertical edge will have length y. And by simple trigonometry, because we know that cos means adjacent over hypotenuse, so cos of theta would be x on r, and so x would be r cos theta. Likewise, we know sine is opposite over hypotenuse from SOHCAHTOA, right? So sine theta is y on r, and so y is r sine theta. So keeping in mind that z is x plus iy, I therefore have that z equals r cos theta plus I r sine theta. Or if I take the common factor of r out, I'm left with cos theta plus I sine theta. Okay, this form here that I've just written, this is called polar form. And this is another popular way of describing complex numbers. So when you write a complex number in this form, you're describing it using its distance from the origin, r, and the angle theta, which it makes with the positive real axis. So one of the things that you need to know how to do is to take a complex number, which is in Cartesian form, and to convert it into polar form, or vice versa. Okay, so let's have a look at this example. So we've got the complex number minus 2 root 3 plus 2i, and what we want to do, we want to write this in polar form. Okay, so the first thing that I recommend you do with questions like this is to draw what's happening. I find that if you draw what's happening, it really helps reduce the chance of making silly mistakes. So let's have a look. Let me draw my Argand diagram. Okay, so minus 2 root 3 plus 2i, that's going to be in the second quadrant because the real part is negative, minus 2 root 3, and the imaginary part is positive, 2i. Okay, So you got some point here. Okay, so this point corresponds to Z, right? Now I want to figure out the distance of this Z from the origin and the angle it makes with the positive real axis. Okay, so what I do is I say I want to figure out, let me change color one sec. I want to figure out this distance, right? So let's call this R. And I also want to figure out this angle. So notice with theta, it's always measured from the positive real axis, okay? Now in terms of how I can figure out R and theta, well again, I can make a little right angle triangle. And let's call this little angle here, let's call it alpha, okay? Now, let me draw a little bit bigger, just so we can clearly see what's happening, the triangle that we're working with. So I got this right angle triangle, okay? We're calling this alpha, this is R. Now this vertical edge, this is 2, because it corresponds to 2i. This horizontal edge, that has length 2 root 3. So it corresponds to the point -2 root 3. Now, by simple trigonometry, right, or by using Pythagoras' theorem, we know that r squared has to be 2 squared plus 2 root 3 squared. Or in other words, r squared has to be 16, which means r is equal to 4. Okay, so it's not plus or minus 4, because keep in mind r is a distance. So it can't be negative. So r has to be 4. Now in terms of the angle alpha, well, just using simple trig, we know that tan alpha, right, tan is opposite over adjacent. So you get 2 over 2 root 3, which is just 1 over root 3. Now, you need to know your trig for these kinds of questions. So in particular, you need to remember your exact triangles. So in this case, you need to remember this important triangle here. So root 3, 1, 2, pi on 3, pi on 6, right? So you have a look at this triangle and try to see tan of what angle gives you 1 on root 3. So you can see that the answer is going to be pi on 6, right? Keeping in mind tan is opposite over adjacent, so alpha is pi on 6. So you need to make sure you remember that triangle. Of course, the other important triangle, it didn't come up in this question, but it will definitely come up in other questions, right? You also need to remember the other exact triangle as well. So the one that goes 1, 1, root 2, pi on 4. That one's also very important. Anyway, don't want to get off track. So we know alpha is pi on 6. Now if alpha is pi on 6, notice that theta, theta is pi minus alpha. To see why that's true, well, theta is when you go half a revolution and stop alpha short, basically. So half a revolution is pi, up until here is pi, but you're stopping alpha short. So you're going to get pi minus alpha. Now we know that alpha, we just learned, is pi on 6, so theta is 5 pi on 6. So therefore, putting it together, I can say that z, or minus 2 root 3 plus 2i. So remember, how does the formula go? We said it's r cos theta plus I sine theta. So because r is 4, goes out the front. Cos, now theta was 5 pi on 6, plus I sine 5 pi on 6. And basically what I've done is I've taken that complex number, minus 2 root 3 plus 2i, and I've converted it into polar form. So, pretty straightforward. I guess the main thing is just drawing it and making sure you're on top of your trigonometry. Otherwise, it's not exactly something tricky. Can't really go wrong. So that shows you how to go from Cartesian to polar form. You might be wondering, well, how do you go from polar form to Cartesian form? Okay, going the other way, that's actually super easy. So if you want to go the other way, so let's say instead of giving us z in Cartesian form, let's say they gave us z in polar form. So let's say they gave us 4 cos 5 pi on 6 plus I sine 5 pi on 6, and let's say we wanted to convert this into Cartesian form. Okay, it's super easy. You literally just evaluate the cos and the sine. That's all that you do. So you know 5 pi on 6 is an angle lying in the second quadrant, right? You know cos is negative in the second quadrant and sine is positive in the second quadrant. And at 5 pi on 6 makes an angle of pi on 6 with the horizontal axis. So this is the same as saying 4 times negative pi on 6 plus I sine pi on 6. Now using our exact triangles, so this guy here, I know that cos pi on 6 is going to be minus root 3 on 2, and sine pi on 6 is a half, so I get I on 2. Multiply this by 4, so I get minus 2 root 3 plus 2i. So you can see that going from Cartesian form to polar form is very straightforward. So the main thing that students struggle with is going from Cartesian to polar. And like I said, it's just a matter of drawing it and being on top of your trigonometry.